Hello everybody, this is Engineer Rodolfo Ocate from Haro, Iloilo City. These are my future topics to be discussed, 1 to 8. Okay. Be sure to subscribe, push the button. I will be glad if you do so. Okay. We have this fifth series of session given the 3-span beam. We have the basic equation for the 3-moment equation, this one. Now this uses the 2-span at a time. You consider 2-span at a time. Then here in this problem we have two unknowns, moment B and moment at C. We have two equations. We need to have two equations. So one equation is derived from 2-span ABC, one equation. Then the other equation is if you consider the span BCD, or 2-span at a time, using this 3-moment equation. Okay, before that we have to know this. We need to know this, how to solve these values. Okay, consider this span AB as a simple beam. Solving for the reaction, this is just a simple beam. Neglect this BCD, just AB. The reaction RA is 7, and this is just dummy reaction. It is not yet the true value of reaction at A. Then simple beam, the reaction RB is 1. Then a reaction at A of 7, you multiply this by 6, it is 42. Or bring this force and make a moment at B, or pivot at B, it is 42. This 8 concentrated load is going down, so multiply 8 by 4 is 32. Start here, then end here. The moment is negative with respect to B, so minus 10. While here, if you consider this as a simple beam, the dummy reaction RB is 11, and RC dummy reaction is 14. Now to solve this, the reaction RB, bring that to this pivot at the base of a triangular lobe at a distance of 3. So 11 times 3 is 33. Down below, moment due to triangular load is 1/2 6 by 3, or 9, minus 9 going down. This one pivot to this area. The reaction is 14 times 4. Bring this 14 to pivot here is 56. The uniform load, the moment is 4 by 4. Center distance times 2. 4 by 4 times 2 is 32, negative. Here, consider as a simple support, we make this data. The reaction is 9.9 RC, then RD is 13.3. Now bring this 9.9 multiplied by 5 is 49.5. 4 times 3 is 12, and uniform load of 3 times 5 times 2.5 is 37.5. We need this to solve the constant here and here. So when we consider a two span at a time, just like ABC, the moment by parts on the left AB is this one or this formula. On the right, this one BC. The moment by parts is this one. We consider two span ABC. Okay, so we follow this formula. Consider span ABC. This is left, this is right of the span. The moment at A is really 0. Moment at the center of ABC is twice moment at B. Then distance is L1 plus L2. Add this and this. So 6 by plus 7. This one. And the moment on the right, this one, is moment at C. The distance is L2 or 7. Then the constant, this is the moment left, constant on the left. This is 6 over L1 or 6 over 6, then 1/2 area 1. This is area 1. 1/2 42 by 6 times distance from the left is 2/3 of 6. From here up to here, centroid is 2/3 of 6. The span on the left, the origin must be on the left. Then minus 10 by 2, distance is 4 plus 1 is 5. Then the triangle is 1/2 32 by 4 times distance of from the left 2 plus 2/3 of 4. Okay, this is for the left span. The right span, this one, the right span 6 over L2 or 7. This is 7. The right span is BC, 7. Then the area 1/2 33 by 3 times distance from here. Origin must be on the right of the right span. So this is 4 plus 1, 1/3 of 3. Minus this one. 1/4 3rd degree, 1/4 of 9 by 3. Distance is 4 plus 1/5 of 3. Then here, this still belong to the right span. Plus 1/2 56 by 4. Then distance from here is 2/3 of 4. 2/3 of 4 from here up to here. Then minus 1/3 second degree. 32 by 4 times 3/4 of 4 from here up to here. Then equate to 0. Since there is no settlement of the support, this thing must be 0. Then simplifying, this is 13 times 2, 26, 7 MC. The constant here, these constants are positive. So if you transfer this to the right, it becomes negative. Constant is minus 437.148. And this is equation 1 for span ABC. Now considering the span BCD, two span at a time. Left moment is B, so 7 moment B, the center moment twice moment of C, the sum of the span of the two span 7 plus 5 1. Then the moment at this one, the right span here at D is 0. Actual moment at D is 0. Then for the constant, we have this first span, second span of BCD. 6 over 7, area 1, this one, area 1, 1/2, 33 by 3, distance from the left is from here up to here 2/3 of 3, then minus 1/4 9 by 3, distance from here up to here is 4/3 of 3, then plus this one 1/2 56 by 4 times distance from here B is 3. This is 3 plus the centroid of 1/3 of 4. From here 3 plus 1/3 of 4, then minus 1/3 32 by 4, distance from B is 3 plus 1/4 of 4 or 1. 3 plus 1/4 of 4 or 1. Then the second span plus, still plus. Okay, for the second span, we have 6 over 5. The area is 1/2 49.5 times, okay, the distance is from the right. For the right span, distance is from the right, so 1/3 of 5, distance here 1/3 of 5, then minus 1/2 12 times 3 times 1, centroid is 1, then minus 1/3, this is second degree, 37.5 times 5, okay, 5 times 1/4 of 5, 1/4 of 5. Now simplifying 7 MB, this is 12 times 2 or 24 MC. Then the constant, we have 6 over 7, positive, negative, positive, negative, positive, negative, positive, negative. Then the second span, 6 over 5, positive, negative, negative, positive, negative, negative. Simplifying this is positive. The whole thing is positive. Transfer that to the right, it becomes negative. Now this negative is that it justified that the moment at B is negative. Usually negative, negative also at C. then the whole thing negative. These two terms are negative, or justify that this is negative. Then solving the two equations, moment at B is minus 12.49, moment at C is 16,059. Then consider the span, AB. Cut section here, cut section. There appear a moment at B to be negative, or direction here is clockwise. Direction here is clockwise. Value is moment at B minus 12.49. Okay. Solving for RA, 6RA, this is 6, is equal to 8 times 4 plus 10. The direction of the moment of 10 and 8 are the same. It is counterclockwise with respect to B. So, positive, but the direction of the moment at B is minus 12.49. Then we have the equality. I can solve RA as 4.918 kilonewton. Now solving for RB, cut section here at C. Consider the left cut section of C, and that is ABC. This is given now, RA given, RB is unknown, everything here on top are given. So I can solve RB. So moment at C, RB times 7 plus direction is clockwise, RA 4.918 times distance of 11. This is 6 and 7. Distance of RA is 6 and 7, 13. 6 and 7, 13. Then minus 8 times 11. Okay. 4 plus 7, 11. Then minus 10, the moment 10, the same direction as the 4, the 10. Minus 10, then minus the triangular is 1/2, 6 by 3, distance is 4 plus 1/3 of 3. Or 5. 4 plus 1. Then minus this uniform load, 4 times 4 times 2. Now the sum of all the moments here on the left is equal to the moment on the right, moment at C, 16.059. All of these moments is equal to this moment on the right of C, or 16,059. Then solving for RB, it is 13.572 kilonewton. Solving for RD, when you cut section on the right of C or CD, there appear here a moment of C when you cut the section at C. So we consider the CD solving for RD. RD times 5 is equal to, this is counterclockwise, is equal to clockwise 3 times 5 times 2.5 centroid of 5, then plus 4 times 2, and we have the moment at C as minus 16.059. Okay, the direction of the moment at C is counterclockwise. This is clockwise, opposite of that, of this to positive, it is negative. RD now is 5.888. Now to solve for RC, consider the BCD or the right of the cut section at B. I will solve RC. So 7RC going counterclockwise plus the reaction at D, 5.888 times distance of 12, 7 plus 5, 12, then equal to opposite of this, these two are counterclockwise, equal to clockwise 3 times 5 times distance of 7 plus the centroid of this 2.5, 7 plus 2.5, 9.5, then 4 times 9, 7 plus 2, 4 times 9, then 4 times 4 times 3 plus 2 or 5, then the triangle 1/2 6 by 3 times 2/3 of 3 or 2, then there is a moment at B minus 12.49. Simplifying, RC is 27.622. Okay, the four reactions now are given. You check this, the sum of RB, RB, RA, RB, RC, RD, this four must equal to the sum of the vertical load here on top. Okay, then given now the four reactions, we can draw the shear and moment diagram of this shear and moment diagram. So this is the shear diagram and this is the moment diagram. These two are under the topic of the strength of material, so I will not explain on these values. Okay, then to challenge you to solve a different one, I give this sample problem. Given the moment of 14, instead of 10, the moment must be 14. Then the three loads, W1 8, W2 6, W3 is 3. Okay, then drawing the moment by parts, we have this lot of values. Be sure to check first before you proceed for the equation. Check this first, then the moment answer for that MB is this, MC, then RA, RB, RC, RD. Okay, then another set of practice solving the same figure, only that the data moment here is reverse, minus 8. reverse as this one, clockwise, -8. Then W1, W2, W3, change that to this data. The moment by parts, we have this, then the moment at B, moment at C, RA, RB, RC, RD. It's good to solve so that you will have a confidence later to solve any problem related to three moment equation. I hope you subscribe. Then that's all. Thank you.